percentages today.
Yes.
Before we start, let's have a quick recap of what we were looking at last time.
Yes.
So I just want to go over the percentage multiplier a couple of times. So when we're doing reverse percentages, forward percentages, what we do is we take the number and then we multiply by our multiplier, and that gives us the percentage amount. Okay? If we're going reverse percentages, we take our percentage multiplier and then we divide by that amount. Okay?
Yes.
So let's start with percentage multiplier. Now, if I want to find, let's say I want to find 20% of 200, start by finding what's the percentage multiplier here. What do I need to multiply 200 by to find 20%?
0.2.
0.2, perfect. So the percentage multiplier of 20% is 0.2. So I take 0.2 multiplied by 200, which gives me 40.
Yeah, 40.
Yeah. So then I know that that you've looked at a slightly different method where you find 10% by dividing by 10. So for example, 20 would be 10% of 200. And then to find 20%, we would multiply 20 by 2, which gives us 40. Okay? So you can use the second method to double check our answers.
Yeah.
Okay, let's do, if we're finding 17.5% of 100, what's the percentage, let's do 1,000. What's the percentage multiplier going to be?
0.175.
Sorry? 0.175. Yeah, perfect. So we do 0.175 times 1,000, which is
1,000. Okay, so 5, 1, 2, 3, 4, 5. And then 0, 1, 2, 3, 4, 7. 0, 0.
So remember that the multiplying something by 1,000, think about what that's doing to the decimal place.
It's going to make it lower. 0, 0, 0, 5, 7, 1. It's going to go, it's going to be 70,500.
Not quite, that's a little bit too big. So I'm just going to go through. So if we have 0.175, we're multiplying by 1,000. So when you multiply a number by 10, multiple of 10, what we do is we take the decimal place and we move it to the right.
Yes.
So what it's doing is it's jumping 1, and it's jumping 3 spaces. One's for each 0. Okay? So 1, 2, 3. So the decimal place ends up there. So what number do we have?
175.
If we have a state. Yeah, 175. Exactly right. Okay?
Yes.
Now, if I was going the opposite way, let's say I've got, let's take 200, slightly different example. This is practice with a few different numbers. 215 divided by 100. How would you work out this one here?
So the decimal point is over here. And
Yeah.
dividing will go this way. So 2.15.
Yeah, perfect. So this is going to be 2.15. Okay, let's do 3.92, and let's multiply that by 10,000.
So 1, 2, 392.
Not quite.
No,
How many
the decimal
places
goes
are you?
up 4.
Yeah, so we're moving the decimal places 4 spaces.
So
So it's not going to be 392. What do you add? Yeah, perfect.
2
You need
zeros.
to add those 2 zeros.
Yeah, and then the decimal.
Okay, so if you write the whole number underneath, what the number looks like. Bless you.
Thank you. It's gonna be
Yeah.
39,200.
Perfect, 39,200. Exactly correct. Okay, good. Just a little recap. Yeah, this one here, so we're going to give us 175 as our answer.
Yes.
Okay, let's do 33% of 200.
So what we're gonna do is 0.33 multiplied by 200. Yeah.
Yeah, good.
Will it be 66?
Yeah, perfect. Exactly right. So we can split this into 2 calculations. We can turn this into 0.33 times 2 times by 100. So that might make things a little bit easier to solve. Okay, good. So I think we've got the hang of percentage multipliers. So let's now try and apply those percentage multipliers in reverse percentages. So when we have reverse percentages, what we have is we don't have 100%. So in these examples here, we had 200, we had 1,000, and we had 200 again. Those were the 100% values.
Yes.
Now in these next ones, the value we have in the question is not 100%. And the goal of a reverse percentage question is to find what would 100% be.
Yes.
Okay? So let's take let's take an example. We're going to say 80% of a number
Yes.
is 8,000.
Yes.
Now we're going to try and find what is 100% of this number.
So what we're going to do is equals to 80%. So
Yeah, perfect.
So we need to do first we're gonna find out what we're going. Okay, so we need to find 20%.
Not quite. So we can't use this number here to find 20%. Why not?
Because this is just 80.
Yeah, exactly right. So we would need to first find 100%, then find 20%. So we can use a kind of a method like this. What percentage can we find? So remember, if you want to do this method, you need to do the same thing on both sides.
Okay.
What can we do on both sides to find a nice percentage that will help us find 100%?
Divide by 2.
Yes, we could divide by 2. I was thinking we could divide by 8 on both sides. If we divided by 8, what percentage would we find?
10.
10%. Yeah, so if we divide by 8 on both sides, we would actually find 10%. And what's 10%? And what's this said?
1,000.
Yeah, perfect. So 10% of our number is going to be 1,000.
Now what we're going to do
Now,
is multiply 1,000 by 10.
yeah, exactly right. That's going to give us 100%. Because we know that if we multiply 10% by 10, we would get 100%. So remember that multiplying by 10, what's that going to move the decimal? How does that move the decimal place?
The decimal place is going to go right. So it's going to be bigger.
Yeah. Yeah, that's exactly it. We've got it. It's perfect.
0, 0, 0, 1.
Yeah,
10,000.
that's perfect. That's exactly it. Okay, awesome. So you've definitely got the hang of this, and this is maybe a slightly different method. But let's have a look at now how we could solve this using the percentage multiplier. So once again, we know that 80% is equal to 8,000.
Yes.
Now, what's the percentage multiplier for 80%?
0.8.
0.8, perfect. So if we're going for a reverse percentage, usually we would multiply by the multiplier. If we're using a reverse percentage, what do we do with the multiplier?
Divide.
Yeah, so let's divide this number here by 0.8.
Yeah, I'm sure.
So I would maybe use a fraction division. Have you looked at fraction division before?
No.
Okay, so let's maybe, because I think it would be quite tricky. Well, you could do it this way, but I think it might be quite tricky. So I'm just going to go through how to do this. So we have 8,000 and we're dividing by 0.8. So what we're doing here is we're just writing the calculation as a fraction. Remember that the line in a fraction represents divide.
Yes.
So what we're writing here is we're writing 8,000 divided by 0.8.
Yeah.
Okay? Now, what's a common factor? So we know that when we have fractions, to simplify fractions, we use equivalent fractions.
Yes.
And one thing that we do is we look for common factors between the numerator and the denominator.
Yes.
So what's a common factor between 8,000 and 0.8? Well, how can we, what can we divide both of those by quite nicely?
0.8.
No. What did you say, sorry?
0.8 because it goes into 8. No, yeah, it will, because if we multiply it by 1,000, it will go to 8,000.
You're really close. Not by 1,000. We have to multiply it by
100.
No, it's the other way. So
Multiply.
no, 10,000.
Yeah, 10,000.
Okay. So what maybe we could also do is if we change this fraction into this. Yeah. So we now multiply the numerator and denominator by 10. So we multiply by 10 over 10. Here.
Yes.
So these, can we see that this fraction here and this fraction here are the same?
Yes.
Yeah. And then 80,000 divided by 8 is going to give us
10,000.
Yeah, 10,000, exactly. Okay, perfect. Good. And then we can see that we also got the same answer depending, both methods gave us the same answer. Okay? So kind of one of the benefits of using this reverse percentage multiplier is that doing this division, while the division itself might be quite tricky sometimes, this method will always work. But if we use this method here, imagine if you've got a percentage like 32%, it's quite tricky to then find something that we can then work back to get 100%. So using this method will always give us exactly what we're looking for.
Yes.
In less steps as well. So we just look for the percentage multiplier, we divide by the percentage multiplier, and then we're done.
Yes.
Okay, so we're going to now have a look at some questions. So we're going to have a look at some sale questions, so similar to what we were looking at last time.